For years, businesses deployed AI to analyze data or generate text. Now, we are moving towards systems that independently execute tasks directly inside your workflows. To understand the trade-off, we have to define the operational boundaries of traditional AI. Think of it like a highly advanced calculator. It operates entirely on rigid, static, if-then logic. This reliance on fixed rules provides a massive operational advantage. Because the logic is strictly defined, implementing traditional AI software is fast and cost-effective. But that same strict logic is its fatal flaw. The moment a customer asks a question outside the pre-programmed FAQ, or a supply chain deviates from its normal schedule, the system fails. The workflow stops completely until a human steps in to manually override it. Agentic AI operates on a different architecture. Instead of feeding it static rules, you give it a specific goal. Deploying agentic AI offers several levels of control. Businesses choose where to sit on the spectrum of autonomy based on their exact tolerance for risk and their specific industry regulations. This quadrant chart maps AI agents. The x-axis tracks implementation complexity. The y-axis tracks autonomy. In the bottom left, reactive agents use simple condition-action rules for static environments. In the middle, human AI collaborative agents are the safest entry-level upgrade for risk-averse organizations. These collaborative agents process massive datasets to offer real-time insights, like evaluating a patient's history for clinical decision support. They draft the solution, but they are hard-coded to require a human expert to authorize the final action. The financial reality of collaborative agents is straightforward. They significantly boost your team's accuracy and output speed, but they do not eliminate headcount. Context-aware agents push this a step further, adjusting recommendations dynamically based on the user's geographic location, the specific time of day, and historical behavioral patterns. However, installing these mid-tier agents introduces a new internal challenge. You have to allocate time and budget to retrain your existing staff, ensuring they know how to critically evaluate the AI suggestions rather than just blindly clicking approve. These entry-level systems are the optimal path for companies that want to clear out workflow bottlenecks, but operate in regulatory environments where removing human oversight is too great a liability. If your objective is to scale your output without scaling your payroll, we have to look at the top right quadrant: enterprise-grade, fully autonomous systems. This flowchart breaks down a goal-oriented agent. It receives an objective, queries an API, retrieves proprietary data, and executes the action independently. If it hits a roadblock, like a broken API, it analyzes the failure, rewrites its plan, and executes an alternative solution. Designing this level of autonomy requires massive upfront capital. You have to hire specialized engineers to integrate the large language models, structure your internal data, and select the precise algorithms necessary for the agent to reason accurately. The absolute limit of this technology is a multi-agent system. It functions as artificial swarm intelligence. Instead of one massive algorithm doing everything, a multi-agent system uses several distinct AI agents. They take a massive problem, divide it into subtasks, share information with each other, and execute collaboratively without central control. You deploy this architecture for highly dynamic, distributed problems. It can optimize a live supply chain, adjusting to weather delays across 3 continents, or coordinate adaptive traffic grids in a smart city. But operating at this scale exposes you to a critical architectural vulnerability: compounding errors. If a single agent retrieves flawed data or hallucinates a variable, that error propagates through the entire swarm, corrupting the final output. Because of that compounding risk, achieving true autonomous scale requires rigorous sandbox simulation. You must pay to test the agent's behavior in a secure, replicated environment for months to ensure safety before it ever touches your live business operations. Understanding the technical capabilities is only half the equation. The actual financial risk lies in how you procure and build these systems. Misaligned development models will burn through your budget fast. Many engineering teams utilize the agile build and scale engagement model, which breaks the project down into flexible, sprint-based development cycles. The distinct advantage of the agile model is continuous iteration. As real-world feedback flows in from users, developers can rapidly adapt the agent's behavior and reasoning pathways. The financial risk of this model is the lack of fixed pricing. If you do not rigidly define your core business objective at the start, you will experience massive scope creep, paying for endless optimization sprints. Launching custom agentic AI requires an intensive 9-step development lifecycle. While system integration is complex, the absolute non-negotiable hurdles are data collection and custom training. The output is entirely dependent on the quality of the proprietary data you feed the model. To determine your exact readiness for an upgrade, let's walk through this final decision tree flowchart. The first question, is your workflow static? The yes branch leads to stick to traditional AI. If your daily workflows are highly static and require zero contextual reasoning to execute, save your capital. Stick to the predictability of traditional AI. The no branch asks, can you tolerate occasional errors, branching to human AI collaborative for no. If your workflow is dynamic but the cost of a mistake is severe, utilize a strategy to test human-in-the-loop collaborative agents before taking larger risks, and autonomous goal-oriented systems for yes. But if your industry operates under dynamic constraints, you own deep proprietary data, and human bottlenecks throttle growth, allocate capital toward goal-oriented and multi-agent systems. Build your agentic AI as a custom operational infrastructure. By training the system on your unique data, you create an engine that learns your workflows and establishes a proprietary moat against your competitors.